Hey y'all, so for this first problem, we've got a side angle side scenario, and when we want to find the area, and this is the information that's given, we want to use sort of a modified version of this classic area equals 1/2 base times height formula for the triangle. Obviously we don't know what the height is here. The height is going to be this distance, but we can compute it when we look at this as a right triangle. And use our trigonometric ratios to find that. So we talked about that a little bit in the notes video, so I'll just kind of jump right to it. It's going to be 2 times the sine of 50 degrees, and that's what the height is going to be. So we're going to plug everything in here, substitute 4 for the base, and we're going to substitute 2 times sine 50 for the height. And then we're going to plot all this in the calculator. We probably could find an exact value here if we were to use some combination of those identities we talked about in the previous unit. But for right now, we're just going to get an estimated value here. So I'm going to put all this in the calculator, and I should get a rounded answer of 3.064 square feet for the area of that triangle. So that's A. Let's take a look at B. So here's B. We've got a triangle where we know the 3 sides. No angle measures like in the last problem. So when we have this side scenario where we know all 3 sides and we want to find the area of it, we are going to use Heron's formula, which, let me remind you what it is. It's A equals the square root of S. Now S is half the perimeter. So we'll have to compute that in a little bit, but you'll see that's not terribly hard. Times S minus A. In this case, it doesn't really matter which one's A, B, C. We'll go ahead and just kind of fill in whichever one you want. S minus B and S minus C. So all these 3 values are known. The only one that's not explicitly given is this S, which again is half the perimeter. The perimeter here is 3 plus 2 plus 4. So 5 and 4 is 9. Half of that's 4.5. So we'll go ahead and plug everything in here. The square root of 4.5 times 4.5. Now I've labeled this A, B, C. These are not labeled on your homework, but it doesn't really matter which one's which. Okay, so I just kind of go in order here. Minus 2, 4.5 minus 3, 4.5 minus 4. This is, again, not something that you would, let me zoom out here a little bit so you can see this. This is not something that you would calculate by hand. I mean, I guess you could, but there's no reason to. Once you put all that in your calculator, you should get about 2.905 square feet. And that's B. Let's take a look at C. Now C is an example of one of the more basic kind of area problems. This is something you probably did like way back in middle school, where both the base and the height are explicitly given. There's not a lot to say about this one. It's just 1/2 base times height. In this case, the base is 4 and the height is 2. So, I mean, come on guys, you don't even need a calculator for this one. 4 times 2 is 8, and half of 8 is 4. So the area is going to be exactly 4 feet squared. That one's pretty easy. Let's look at D. D is like B in that we know the lengths of all 3 sides. We're going to again use Heron's formula here. I wrote out the formula earlier, so I don't really feel like we need to do that again. Let's see if we can figure out half the perimeter here for that S value. 3 and 4 is 7, 5 is 12, half of 12 is 6. So our S value would be 6 here. So the square root of 6 times, let's see, 6 minus 3 times 6 minus 4 and 6 minus 5. Again, it doesn't really matter which one's A, B, and C here. You could swap those out. Multiplication is commutative, so it doesn't really matter what order you multiply these in. So I'm going to put all that in the calculator, and this one actually works out pretty nicely. You might not even need a calculator for this one. This could be a non-calculated question, because look at this. We got 3 times 2 times 1. So forget the times 1. 3 times 2 is 6, times 6 is 36, square root of 36 is 6. So we get 6 square feet, exactly. All right, so that completes number 1. So in number 2, we get this diagram for just this generic triangle with the sides and angles labeled as just like A, B, and C, A, B, and C. And then each of these individual problems like A, B, C, D, they all are going to give you like 3 different pieces of the triangle. Now, since you're using that same diagram for all these, obviously you do not want to consider this to be drawn to scale. For the first problem right away, we see that this angle C is given as 120 degrees. Obviously that doesn't look like 120 degrees. That should really be an obtuse angle, and it does something like this. But that doesn't really matter in terms of how we solve this problem. So as long as you've got everything labeled correctly, you should be good to go here. So let's go ahead and compute the area of this one. Just like we did in number 1, we're going to use the 1/2 base times height formula. We don't know the height, but we can compute that by constructing a right triangle like we did in number 1 and multiplying this, what would be the hypotenuse of that triangle, 4 times the sine of 120, and that should give us the height. So let's go ahead and do that. We'll have the area equals 1/2 base times height, and I'll just write this once for each of these so that you probably have it written down somewhere. You don't have to write it over and over again. But let's go ahead and plug everything in. We've got A equals 1/2 times the base, which is 6, times the height, which would be 4 times the sine of 120 degrees. Put that all in the calculator, and we should get approximately 10.392. There are no units given on here, so like in number 1, all the side lengths were given in feet, and so we were able to say that the area would be in terms of square feet. Here there's no units given, so if it was just units, you would say square units, but that's not even given either, so we're just going to leave it as a numerical value, 10.392. The reason I'm going 3 decimal places here is just because on the AP test next year when you take calculus or statistics and you take the AP test, they require up to 3 decimal places. So as I put this in the calculator, I really just need those first 3 numbers. So that's A. Let's take a look at B. All right, for this one we've got looks like we've got a side angle side scenario. So when I go to sketch out my triangle here, make sure I can fit it on here. All right, there we go. Something like that. We're going to label this one as 43 degrees. And then the 2 side lengths are going to be 57 and 85. Okay, so here's my triangle, and we are going to use the formula that, the same formula we've been using for side angle side situations, which looks like this. Really it's based on 1/2 base times height. So the base here I'll use 57, and the height I'll have to calculate using the angle measure. So it'd be like 85 times the sine of 43 degrees. This is something we're just going to put into the calculator. So we'll say the area is approximately whatever this equals. So let's see. Let's pull up the calculator. Make sure I'm in degrees here. This thing will default back to radians on me. Okay, so now we're going to type it in. We get 1/2 times 57 times 85. Oh, missed a number there. 57. Okay, why is it not clicking on me? 57 times 85 times the sine of 43 degrees. That's the area here. It's approximately 1,652, say 1.141. I'm not going to be too picky about the rounding here, and this is just going to be units squared. Okay, you don't really need to put that either. Let's go ahead and box our answer, and that's it. That should be our answer for this one. So let's look at the next one, 3A. Kind of a similar situation here. It's going to be, it's actually going to solve it out exactly the same way. So I'm going to just copy and paste all my work from up here and change the numbers to match the problem. All right, so in this case, the angle measure is 5 degrees. This side should be 22, 4.5. It doesn't really matter which one you put in which position here, as long as they're both, as long as neither one is this side over here. So you get 1/2 times the base, times 4.5 times the sine of 5 degrees. Remember, this right here is how we're calculating the height. So this height right here from this vertex intersecting this side perpendicularly. And so let's go ahead and type all that in. So we got 1/2 times 22 times 4.5 times the sine of 5 degrees. Okay. Should be a pretty small triangle, honestly, because of this 5-degree angle, is incredibly small. So it'd be a very skinny triangle. This is not, this sketch is definitely not to scale. So yeah, we get a very small area here. D is yet another one of these side angle side scenarios. So we'll just go ahead and set it up. A equals, or the area equals 1/2 times the base, which I'll use 64. This one's set up a little nicer, times the height, which would be 105 times the sine of 72. So we're going to put all that in the calculator. Really taking advantage of our calculator here. And we should get 3,195 and just over a square unit. So computing these areas is not too bad, as long, after you do a few of these, you'll kind of just get in the habit of knowing exactly where everything goes. So let's do another one. Let's take a look at E. E is basically set up the same way again. So we've got the area is 1/2 times the base times the height. And I feel like we've already done enough of these so that hopefully it's not too bad. Now this one's sine 30. 30 is one of our common values around the unit circle. So we should be able to do this without a calculator. No judgment if you use the calculator here, but look at this. We're multiplying by 1/2. Like, this is going to be pretty easy. So let's see if you remember what sine of 30 is. Let's see, 30 degrees. It's going to be about here. Okay, the coordinate here is √3/2, 1/2. So the sine of 30 would be 1/2. So we've got 1/2 times 1 times 3 times 1/2. 1/2 times 1/2 is 1/4, and 1/4 times 3 is 3/4. So 3/4 is 0.75 square units. We don't know we don't know if it's feet or not because it's not labeled. So that's that. If you did put this in the calculator, no worries. But in the future, this may be a non-calculator problem because this is one of those common angle measures. All right, well that's E. There's one more in number 2, so let's take a look at F. So F is like one of the other problems that we did where we do want to use the 1/2 base times height because we got a side angle side here, but the base is not as clearly defined because we don't know like this horizontal piece, but that's okay. We can just rotate this like we did the other problem and pick one of these other sides to be our base. So I'll just go with this 6 as my base. It doesn't matter if you choose 10, you're going to get the same answer. I think we saw that. What was that on B or C? I don't know. Let's take a look at F though and calculate this out. We've got the area equals 1/2 base times the height. So we got 1/2 times, I'm going to use the base is 6, so my height would be like right here, and I'll use 10 times sine 45 as the height. So 1/2 base times the height. Now 45 degrees is one of our common angles around the unit circle. This is going to be root 2 over 2. I kind of like just throwing this in the calculator anyway. We could definitely get an exact answer here, and it would be like something root 2 over something. Oh, well, you know what? Let's go ahead and find out what the exact value would be, and then we can find the estimate too. It doesn't hurt to do both. So we have 1/2 times 6 would be 3. 3 times 10 is 30. So we have 30 times root 2 over 2, sine 45. So 30 divided by 2 would be 15. If we were given an exact, if I were to ask for an exact area here, it'd be 15 times root 2. If you were to put it in the calculator, you would get approximately, let's see here, 21.213 square units. For number 3, all these problems on number 3 are going to require the use of Heron's formula. So let me just write it one time for all of these problems. The area is going to be the square root of S, which, if you'll recall, is half of the perimeter. So like in this case, the perimeter would be 8, and 6 would be 14, so it would be 7, times S minus A, S minus B, and S minus C, where A, B, and C are the 3 sides. And it's up to you which one is A and which one's B, which one's C. That doesn't really matter. So that's Heron's formula, and so that's what we're going to use for all these problems, or all these examples on problem 3. So let's go ahead and plug everything in. The first thing we're going to want to do for all these is actually calculate this half perimeter, this S value. So in this case, it would be 5 plus 3 plus 6 over 2, which, as we said, was 8, and 6 is 14, divided by 2 would be 7. So my S value is 7 here. So once I calculate that, I can go ahead and plug everything in. So my area is going to be the square root of 7 times 7 minus 3 times 7 minus 5 times 7 minus 6. Again, it doesn't really matter which one's A, which one's B, which one's C. You can reverse those if you want. So when you plug all that in, you should get approximately 7.483 units squared, or square units. Now, it doesn't actually give us units here, so we're not going to include any kind of units here, but it would be squared. If this was feet, this would be feet squared, meters, meters squared, and so on. So there's A. Let's take a look at problem B. B is going to be set up the same way. Let's go ahead and calculate our S value. We'd have 1 plus 0.5 plus 0.75 over 2, and that would come out to be 1.125. So that's going to be our S value. I'm going to try to squeeze this in here. So the area is 1.125 times 1.125 minus 1 times 1.125 minus 0.5. It looks like I'm going to run out of room here, so I'm going to scooch this over a little bit. There we go. Times 1.125 minus 0.75. And then we're going to put that whole thing, this whole long thing, in the calculator. You should get approximately 0.182 square units. We're going to work all these out basically the same way. So, just know that we're just plugging these numbers in. We've got to find the half perimeter and then just plug everything in. Let's take a look at C. So this looks kind of fun. We've got a bunch of irrationals here. So when we go to calculate the half perimeter, that would be E plus root 2 plus pi over 2. I would recommend just kind of leaving this as is. Obviously, we can't simplify this. Don't put this in the calculator and estimate yet, because that could throw off your final answer if you're estimating before you get your final answer. So it will be kind of annoying. One thing you could do is you could put this in the calculator by using the store function. Let me show you how that works. So to use the store function, let me get that glare out. There we go. We're going to type in the whole thing. So we got square root of E plus root 2. Oh, I don't need the square root. What am I doing here? We just want a fraction. E plus square root of 2 plus pi over 2. And so what we could do is we can store this in any constant we want. I mean, S probably makes the most sense since that's what we're using here. And so to do that, you're going to press this button down here, store, And then to select any letter, notice all these letters are all in green, so we need to hit the green alpha button and then pick whichever letter you want. So I want S. I'm going to click the S button. And so what this is going to do is when I go to calculate this out, when I put it in the calculator, I don't want to have to type this in a bunch of times. Instead, what I'm going to do is just type that in, type S instead of this, and that exact value will be stored. Not the rounded version, but the exact value, so you don't have to worry about your answer getting thrown off and having a rounding error. So when I go to write this, I'm going to say this area is the square root of S, because I don't really want to have to write this thing all over again. I've already established what it equals, times S minus root 2 times S minus E times S minus pi. And so what I can do in the calculator is just type that in as it looks. So I have the square root of S, just a nice little trick here, times S minus root 2 times S minus, what should we do next? How about Euler's number? Times S minus pi. Oops. Oh boy. Let's get back in there. There we go. And then we'll get our answer there. So we do get approximately 1.918 square units. So there's the area and a little calculator trick to help you so you don't have to type in this whole fraction 4 different times. Let's look at D. All right, so with D, what we're going to do is calculate the area once again using Heron's formula. We need to find the half perimeter, so that's going to be 10 plus 17 plus 9, all divided by 2, which is 18. So we get 18 times 18 minus 17 times 18 minus 10 times 18 minus 9. And we're going to put all that in the calculator, and oh wow, this one works out pretty nicely. It's exactly 36 square units. So that concludes problem number 3. With number 4, we are trying to find the area of this parallelogram, and all these values are given. They do give you the lengths of these diagonals, so what I did was cut them in half so that you could see like from here to here what that would be, and so on. And so the strategy we're going to use is we are going to split this parallelogram up into 4 triangles, find the area of each triangle separately, and then add them all together. So in this parallelogram diagram, one of the things that's going to cut down on our work is to see that this triangle right here is going to be congruent to this triangle right here. All the sides are the same, so we have that side situation where the angles have to be fixed. So these 2 triangles that I've highlighted here in pink are the same, so what we could do is just find the area of one of them and then double it, right? And that will give us the area of both of these. And we could take a similar strategy to find the area of the rest of it, right? We'll find the area of one of these, double it, and then we'll add everything together. So in each of these little triangles, we know all 3 sides, and so what we can use is Heron's formula again. So we're going to basically have 2 instances of Heron's formula. One to find this pink triangle, and we'll double it, and then one to find this white triangle, and then double that, and then add those together. So I'm going to let's first find the 2. I'm going to find the half perimeter for the pink triangle and the half perimeter for the white triangle. Okay, so for the pink triangle, it would be this plus this plus this divided by 2. So let's go ahead and compute that. Let's see here. We got 21.7255 plus 20 plus 4, all divided by 2. Now, just like there you go. Just like I was showing you in the problem, one of the problems on number 3 where we had a bunch of irrational numbers, I guess you could write this out. That's not too bad. Let's go ahead and just write it out. I was going to say we could store that and make it just a little bit easier to type in, but this particular value is not irrational. Okay, so there we go. That's the half perimeter for the pink triangle. For the white triangle, the half perimeter would be 24, oops, let's type that in. 24 plus 21.7255 plus, what was that, 4 divided by 2, and we get 24.86275. So what we're going to do is we are going to find the area of this, double it, find the area of this, double it, add everything together. So let me move this down a little bit. We're going to have 2 of the pink triangles, so 2 times the square root, and I'm just going to write s for now, but when I go to type it in the calculator, I'm going to type this whole thing in. So s times s minus 4 times s minus 20 times s minus 21.7255. I might have to zoom out for you to see it, this whole thing, because what we're going to do here is we are going to add the white triangles. So that'd be plus 2 of them times the square root of that s, it's hard to write in white, so I'm just going to do a little outline here, times s minus 4 times s minus 20 times s minus 21.7255. Notice it's almost exactly the same. Hey y'all, just wanted to make a quick correction here. I noticed that as I was working this out, I had put a 20 right here, just like the last, the area of the pink triangle. But if you look a little closer, this side length is a 24. I think I may have also just typed in the total equation wrong. But if you do type this in correctly and put 22.86275 in for this pink S, and then for this black S, put 24.86275. If you type all that in correctly, you should get about 149.879 square units for your answer. With number 5, we've got another parallelogram, but this time we want the area of the shaded region, so we don't need the whole thing, just these 2 triangles. We will end up with a side angle side situation, so we'll want to use the 1/2 base times height formula where we identify the height, but we need to know this angle measure right here. So luckily we can figure that out because these 2 are supplementary. So if you do 180 minus 115, you end up with 65 degrees, and that will be this angle measure right here. And this will be the same. This one over here is 65 as well. So we don't need to find these areas separately because as you can see, they're the exact same triangle. They're congruent. We got 4, 2, and 65, 4, 2, 65. And so what we're going to do is we're going to compute the area here and then double it. We're just going to find one of these triangles and then double it and get the whole shaded region. So the area is going to be 2 of these, okay, times 1/2 base times height. We need to decide what we're going to use as the base here. I guess I'll use 2. And just think about it like this with the height coming down here. So that would be 2 times 1/2 times the base is 2. The height is going to be 4 times the sine of 65 degrees. And we're going to type all that in, and we should get our answer here. Okay, we should get approximately 7.250 square units. And there you go. So y'all have a great day, and I'll see you next time.